Hi. Today we're going to take a look at something known as formula mass and molecular mass for chemical formulas. Now we've actually seen molecular mass before when we were talking about atoms, and we saw something that's comparable to formula mass with atoms when we talked about atomic mass. If you remember, we defined the atomic mass as the weighted average of all the naturally occurring isotopes of an element. And we saw, for example, that carbon has an atomic mass of 12.0107, and this is measured in atomic mass units, AMU. And then we saw that the mass of 1 mole of carbon atoms, and remember 1 mole is Avogadro's number of carbon atoms, or 6.022 times 10 to the 23rd atoms, that has a mass of 12.0107 grams. And so we usually express this as grams per mole, and that is the molar mass of carbon. Well, we can do a similar thing for formulas for a chemical compound by using by simply adding the masses of all the atoms indicated by the formula. And by the way, the term formula mass is a more general term and one that you should get used to using as opposed to molecular mass. We can deal with that with molecular compounds, but there are some compounds that don't form molecules, specifically the ionic compounds, and so that would be, you technically cannot use that name for those. So just get used to using the term formula mass. It's more generic. It includes molecular mass, but it also includes the masses when no molecules are formed. If we take a look at a simple compound, methane. Now, methane is a molecular compound. It forms molecules. 1 molecule of methane consists of 1 carbon atom and 4 hydrogen atoms. And so by simply adding those masses together, we can get the formula mass for methane. And I like to set these problems up like this. All right, carbon, and that formula indicates 1 carbon atom, and then hydrogen, and that formula indicates 4 hydrogen atoms. And then we put in the masses, and you may need to look these up in the periodic table until you get very familiar with them. But carbon is 12.0107 AMU, and hydrogen is 1.00794 AMU. So when we multiply those out, in the first case we get 12.0107, and for the second one we get 4.03176. Notice I lined the decimal points up here. Be real careful with that because you're going to have to add these two together. Now you may be using a calculator, but you still have to take significant figures into account. So when I add these two together, I get 16.04246. However, because we did addition here, we need to round to the column of the leftmost last significant figure. The last significant figure in this number is the 6. In this number, it's the 7. The 7 is furthest to the left. I'm going to round to this column right here. So I'm going to report this number as 16.0425 AMU. This is the formula mass for carbon. And then just like with the atoms, the mass in atomic mass units becomes the mass in grams per mole. So the molar mass that should be CH4, shouldn't it? Okay, the molar mass of CH4, methane, is 16.0425 grams per mole. So you see that the two numbers are exactly the same, just like they were with our atoms, just have different units. And that's how we calculate formula mass and molar mass from the formula of a compound. All right, let's take a look at a second example here, and this is an ionic substance. If we look at aluminum nitrate, aluminum is Al3 plus. Nitrate is a polyatomic ion, NO3 2 minus. All right, to get the correct formula of this, remember we take the 3 down there and the 2 down there. So we get Al2, and then because we have 3 NO3 units, we have to put that in parentheses, NO3, 3. All right, and what this tells us then is that we have 2 aluminum, 3 nitrogen, and 3 times 3 is 9 oxygen atoms in one formula unit of aluminum nitrate. Notice we cannot actually say a molecule because that's not a molecular substance. So again, we'll set this up. We have aluminum, we have nitrogen, and we have oxygen. There are 2 aluminum atoms. There are 3 times 1 nitrogen atoms, and 9 oxygen atoms involved in one formula unit of that compound. All right, so we go to our periodic table and get our atomic masses. Aluminum is 26.98153.8, and I'm not going to put AMU here. We know what it is, and we can just assume that we have that. Nitrogen is 14.0067, and oxygen is 15.9994. So when we multiply those numbers out, again, remember to line up your decimal points. We get 53.96308, and I am applying sig figs here, so this is the correct number of significant figures. 3 times the 14.0067 gives us 42.0201, and 9 times 15.9994 is 143.9946. Sorry, I have not applied sig figs yet. This one should be 143.995. So let me just make that correction there. And then we can add these together. And when we do that and apply sig figs, we get 239.978, rounding to the third decimal place, because this number right here has the furthest to the left last significant figure. And so our formula mass for aluminum nitrate is 239.978 atomic mass units, and then we could give the molar mass for that as 239.978 grams per mole. Okay?